On YouTube, Middle School Math Man here. This video is going to be on solving systems of equations using the substitution method. So with the substitution method, we are going to be solving the systems of equations by substituting values in for variables. So we have 4 problems to do. So what we are looking for in these problems is we are looking for one of the equations to be solved for either x or for y. So in this case, y is by itself in the first equation. We have y equals x plus 9. So I'm telling you that y equals x plus 9. So I'm giving you what y is. I'm telling you that y is equal to x plus 9. So you're going to take x plus 9 and you are going to plug that in or substitute that into y in the second equation. So let's go ahead and do that. So 3x plus 8. So when I substitute in, remember I need to use parentheses. So 3x plus 8 times x plus 9 equals -5. So now we have a little multi-step equation here. We're trying to solve for x. First thing we need to do is distribute. So once you distribute, the next step, if you remember DC-VAM, the next step is C, which is combine like terms. So 3x plus 8x is 11x. The next is V, which is variable to one side, but my x is already on the left. A is add or subtract, so I'm going to get rid of 72 by subtracting both sides by 72. So 11x equals -77. And now to get x by itself, divide both sides by 11. So we get x equals -7. That is basically half of the problem. So just a reminder, the solution to systems of equations is the ordered pair where the two lines intersect. Now we have half of my ordered pair. We have the x value, but I still need the y value. So let's go back to our original two equations. It doesn't matter which equation you plug -7 in for. It doesn't matter if it's the first one or the second one. But if you're looking at the two equations, the two choices, you should see that the first equation is going to be a lot easier for us. So let's use that one. So now I think that x equals -7, or I know x equals -7. I just solved for that. So you're going to plug in -7 for x in for either one of those equations. And like I mentioned, the first one is going to be a lot easier on us. So we're going to get y equals 2. -7 plus 9 is +2. So now we have an x value and a y value. So if you were to graph those two lines, they would intersect at the point -7, 2. Let's look at the next problem. Now this problem is a little bit more complicated than the previous problem because in this previous problem, y was already solved for. Now if we look at this problem, y or x is not by itself in either one of the equations. However, if you look at the two equations, if you look at the first one, there's no coefficient with the y. So it's going to be easier to manipulate that first equation to get y equals, whatever we solve for. So we need to get the first equation and solve for y. So I'm just going to rewrite it down here. So y equals -2x minus 2. We can't substitute in unless it's x equals something or y equals something. So that's why I did that. So now I'm telling you y equals -2x minus 2. So if I plug that into my second equation, we are going to have to solve for x. So once you substitute in, we need to distribute. So we're going to get 5x minus 6x, or plus negative 6x, minus 6 equals negative 8. The next step in DCVAM is combine like terms, so I have negative 1x minus 6 equals negative 8. My variable is already on one side, so I'm going to add 6 to both sides now. Negative 1x equals negative 2. So I'm going to get x equals 2, positive 2. So now, like we mentioned, that's only half of it. I still need to solve for the other part of my ordered pair. Now again, you could use any of those equations up there. You can even use the equation that we did down here that I just underlined in green. So I'm going to use that one because that one's going to be very easy for us to solve. So y equals negative 2x, but we know x is 2. So we are going to get y equals negative 4 minus 2, so y equals negative 6. So your final answer is going to be 2, negative 6. So both of these examples had one solution, and that solution is the ordered pair. Two more problems. Again, this system does not have x or y solved for itself already. But if you look at the first one, I think that one is going to be easier for us. So I'm going to solve for x because there's no coefficient with the x. So I'm going to get x equals negative 5y plus 4. So now that x is by itself, I'm going to plug negative 5y plus 4 in for x in my second equation. So let's go ahead and do that. Again, remember DCVAM. So once you substitute in, you need to distribute. C stands for combine like terms, so I'm going to have negative 15y, check this out, negative 15y plus 15y. I'm going to underline that, negative 15y plus 15y. You should be saying to yourself, oh, that's 0, those are going to cancel out. And you are right, negative 15y plus 15y is 0. So the only thing that's left is 12 equals negative 1. Now 12 equals negative 1 doesn't really even make any sense at all. So the variables have disappeared, and these numbers are different. 12 equals negative 1. So anytime the variables cancel each other out, one of the options for the answer is going to be no solution. And that is no solution because those numbers are different. Let's look at the last problem. Again, the second equation is going to be easier to manipulate. So I'm going to use the second equation. So now I have y by itself. I'm going to plug that into the first equation. Now when I do that, again, first step is to distribute. So at this point, you might think to yourself, oh, something's a little bit fishy, because the next thing I need to do is combine like terms. Well, if you look, you have 6x minus 6x. Those cancel. So what's going to be left is 54 equals 54. So the variables have canceled, and what's left is 54 equals 54. Those are the same exact thing, same exact number. So anytime that happens, that means you're going to have infinite solutions. So just like how we talked about with solving systems by graphing, you can either have one solution, like we did in the first two problems. We got an ordered pair, one solution, one intersection. Or you could have no solution, so that's when the variables cancel and the numbers are different. Or you could have infinite solutions, so that's where the variables cancel and the number is the same.